Wow, you came back. That's great, because this is the most exciting part of this unit on measurement, really, when we're looking at how we can apply it. What does it mean in everyday life? So that's great. Let's have a look. What's this? I don't think I would drink that. There's something on top. What's that got to do with what we're doing? Oh, I think we can see this one. Truck. How much can this hold, and is the motor big enough to pull that sort of weight? We might have to do some volume and other mass calculations there. And then what about this one? I don't know how they stay up in the water. I really don't. Look at all these containers on top. We might have to investigate that. So these are interesting practical problems. And if we work hard, look what I've got for you just down here. I've got the party starting, but we've got to get through the work first. And I see a few problems here. I think this is not very healthy food. Besides that, I'm going to have to go out and get different flavours. These are both colas, mate. I'll have to go and get better flavours, and I don't think this is very healthy. What do you think we should get? Maybe protein bars? Maybe not such a good party. Anyway, let's do some work. We haven't earned the party yet, so come on down and let's have a look at this one here, the one that I don't think you want to drink. What's that on top? Well, here we are. These are screen clippings from Pearson's, and we're saying if two substances have the same volume, reading this here now, the heavier of the two has the greater density. Okay, so it's how heavy something is for the same volume. A litre of water has a mass of 1 kilogram. 1,000 millilitres weighs 1,000 grams, or 1 millilitre weighs 1 gram. A litre of cooking oil, though, has a mass of less than a kilogram. So each mil weighs less than a gram. And so it will float on the top. Oh, that was cooking oil. I know we shouldn't have had a drink of that. That was cooking oil. Okay, so how do we look at that? How do we work that out mathematically? This is important in science. Of course, maths is the backbone of all the sciences. We really do need to have those mathematical connections and analyses for science to go anywhere. And this is what we say. It's the density of the substance. How dense is it? How much mass per volume? So it's a ratio here. Density equals mass over volume. So that's the first application of our measurement section there. So let's come on down and have a look. And there's our ship. And we'll just come down and have a look at the calculation underneath. The density reducing hollowness explains why large steel ships float in water. Why? Well, if you look at the overall volume, we're not just talking about that, we're talking about down here, underneath. Okay, the overall volume of that is large, but there's a lot of air in it. A lot of it is hollow. So the mass over volume is a rather small ratio. It's not that dense, okay, because there's so much in the volume, there's so much air or hollowness. And if something isn't that dense, why does it float? Well, there was a scientist called Archimedes, and Archimedes' principle says the upthrust when you immerse something in water is equal to, in other words, the force lifting you up is equal to the amount of fluid displaced. So when we jump in the water, we displace enough fluid that we will have an upthrust, and we are not dense enough to sink if we hold ourselves still. Okay, so here Archimedes' principle says we have a big volume of displacement under the water there, and you get an upthrust equal to the weight of fluid displaced, and so that's big enough to upthrust the mass, and the thing doesn't sink. All has to do with how much mass per volume. So come on down here and we have a formula. Density is mass over volume. So density, of course, is a mass like grams per volume centimetre cubed or grams per milliliter. And because 1 centimetre cubed has a capacity of 1 milliliter, or a kilogram per metre cubed if it's bigger like boats, or kilograms per kilolitre. Remember, 1 metre cubed is equivalent to 1 kilolitre. Okay, 1 cubic metre holds or has a capacity of 1 kilolitre. So the mass is in grams or kilograms, and the volume is in centimetre cubed or capacity, millilitres or metres cubed, and the capacity of kilolitres. Have you got it? These calculations can really help us predict what's going to happen. Okay, let's come down and see if we can do a calculation here. So a rock has a mass of 80 grams and a volume of 25 centimetre cubed. Find its density. Write down the formula. Remember, density is how heavy it is for its size in volume. So it's 80 grams divided by 25 centimetre cubes, or 3.2 grams per centimetre cube. And we can write this as this. Not usually done, because it's in the bottom line there. See that, centimetre cubes? So that cube is in the bottom line, so that's a negative power, isn't it? When you have a power or an exponent on a term in the bottom line, you have negative. So you can do that. It is usual, though, to put it in this form. Okay, do you get it? This calculation would allow us to compare how dense bodies were and whether one would, if it was floating, float or not, or float on top of another if they're both fluids. Okay. Now, I want to talk a little bit about mathematics here, and I differ here from Pearson's, but just come down here a bit. Go to there. In Pearson's, they give you a little triangle from which they suggest you can remember the formula. Don't do that. You are but young mathematicians. You know it's mass per volume. If you want to find how heavy something is given its volume, like that semi-trailer full of fuel, how much does that weigh? Well, let's rearrange this equation. We have done this. Maths to the rescue, mate. Mass has been divided by V. To get mass back again, you will multiply both sides by V. So dV equals m. Use the algebraic skills that you've got. You don't need little tricks to remember things. Let's be mathematicians. So to get the mass that something weighs, you multiply its density by its volume. Just watching the units there. If density is in, what will it be, grams per centimetre cubed, then the volume must be in centimetre cubes. What about saying, well, I know the density and I know the mass, what volume does it occupy? Well, let's try and get that V out of there. What will you do? Well, there are two ways. You could say, well, I'm going to multiply both sides by V. So on this side it would cancel and I get m. And then what's been done to V? It's been multiplied by D. We can divide both sides by D. And so you can get that formula mathematically. You might like to do this differently. D equals m over V. Let's invert both sides. Therefore 1 over D is equal to 1 over m over V, which is V over m. Okay, and invert it that way, and then V has been divided by m. We'll reverse that. We'll multiply both sides by m and get the same result. Just check the units when you're using this. So please be a mathematician. Don't use little tricks. Let's use maths to get the formula in different forms so that we can work out anything we want. I think this one here is a good one. Remember the gasoline truck or fuel truck there? If we knew the volume of it and we knew the density of the fluid it was carrying, we can calculate the mass and see whether that was a safe thing to do. To fill that tanker up, and would it be safe on the road, and would the semi-trailer be able to move efficiently? Okay, let's come down and look at some problems now. Here we are, example 15 from Pearson's now. We have a block of metal and we have 400 centimetre cubes of that metal and a density of 1.6 grams per centimetre cube. How heavy is that? Can we lift that, or is it too heavy for us? Do we know? Well, density is mass over volume. Rearrange it. M equals D times V, and then we know here the density is 1.6 grams per centimetre cubed, and we have 400 centimetre cubes, so we have 640 grams. Just watch the units. When we're looking up here, we are seeing that the volume is in centimetre cubes and the density is in grams per centimetre cube. So overall, the weight is in grams there. Okay, so we have 640 grams, and you can check whether with M over V you get the same density as what you started with. So see the idea. It's going to be important. Occupational health and safety. They say, well, okay, you've got this box of let's say metal discs or something, and we know how many are in there. We know their density. Is it safe for a man to lift a box, or a woman, which has 50 discs, 100 discs? Do we know? This is a safety issue. What is the weight that we're asking those people to move around? Okay, let's have a look now at this example. Find the volume this time of a 120 gram piece of gold with density 9.3 grams per centimetre cubed. How big is that? What would its volume be? Start off with the formula. Density is mass over volume. Rearrange it. Volume is mass over density. Let's have a look. We have a mass here of 120 in grams, and here a density of grams per centimetre cubed. We divide by that, and the answer will of course be the volume is in centimetre cubes. We can see the unit up here that's being used to get the density. We reverse that process and come back to volume. We will have centimetre cubes. So it occupies 6.22 centimetre cubes, not a very big area. And you can check your answer, not a very big volume, sorry, not area, volume. You can check your answer here at the end. If you took the mass and divided by the volume that you've calculated, does that check out with the given density? Okay, are you getting the idea? We can get an idea of the volume or the weight if we know the density of the object. This is good practical stuff now. Okay, come down and look at the last example that we're going to use in applications here. This is applications of volume, those most common things where we need to know the volume. Okay, it's called the concentration. How concentrated is that solution? How salty is that solution, etc.? How much dissolved substance is there? And that's called the solute in the liquid, and that's called the solvent if you're doing any chemistry type work there. So, for example, the concentration of sugar dissolved in water is the number of grams of sugar per litre. There it is, that's a concentration. So this is another ratio or rate. So it's the amount of solute or dissolved substance divided by the volume that it's dissolved in. So you can look at how strong the solution is. If that was sugar, how sweet does that taste? And you might use this in making soft drinks or something like this, and working out what the sweetness is in the laboratory, and then making sure when you make mass amounts of the soft drink that you keep that ratio or rate the same, so that each time you make a batch of soft drinks you know what sweetness level you want, and so you stick to that. Okay, here's an interesting one here. The concentration is the amount of solute compared to the final solution, not the amount of solvent added, because obviously the volume of the final solution with stuff added to it will be greater. So you keep adding it and then measure the final volume of the solution, the volume of the final solution. Now just let's clarify that. Let's say we've got a beaker here and we put in solvent, let's say 100 mils, and then we dissolve, let's say, 20 grams of some substance in there. This 100 mils is going to increase in volume. So at the end of it, we are going to have more than 100 mils, aren't we? It depends on the substance here. Could be up to 120. 1 gram of what water occupies 1 millilitre, so it would go up 20, but it could be some other substance, so you need to measure the final volume of this to get the final concentration. Okay, let's go down and see if we can do some calculations. Alright, here we are. Again, another example from Pearson's. We've got a 3 litre jug of cordial is made with 150 millilitres of cordial concentrate. Find the concentration of cordial in millilitres per litre. That's the amount of solute of 150 millilitres. Amount of solution is 3 litres. That's the final volume. After we've added it and stirred it up, that's the final volume. So we've got millilitres per litre. Okay, so that's the idea. How much is in there is what we're saying. Alright, let's have another one. 6 grams of salt is dissolved in water to make final volume, not the water we had to start with, 220 grams of saline solution. This is often used for washing out eyes and things, maybe wounds as well. So you don't want it too strong. So the concentration amount of solute over the amount of solution. This time it's grams per grams of solution. Okay, so it's 5 grams per 100 grams here. If you work this out, grams per 100 grams. So this is grams per 120, and therefore it's that fraction of 100. So you're saying it's 6 in 120. How much is it in 100? So 6 per 120, you then multiply by 100 grams. This is 6 grams per 120 grams, so how much in 100? 100 times that. Okay, so the units can change here, and you can have concentration of grams per mil as well. So just looking at what the question asks is important here. Let's come down and have a look now, just go up here a bit, at some problems. For each of the following, find the density. So there, your standard formula density is mass over volume. For each of the following, calculate the mass. So that's a rearrangement. You can rearrange your formula, calculate the volume, and so on. And then some concentrations down here. Alright, so you might whip through and have a look at those, just like the worst examples, and there's the solutions there. Check them as you go to make sure you're not doing things all around the wrong way. Okay, let's come down now and have a look at some harder questions, some understanding questions now. A river carries sediment from erosion in its catchment, Goulburn. Barry takes a 5 litre sample of water from the river. From this he extracts 30 grams of sediment. Okay, 30 grams, so 1,000 milligrams is 1 gram. And what is the concentration of sediment in milligrams per mil? So that's the amount of that over the volume. Okay, so he's got his final volume of 5 litres. How much solute has he got in that? So that is the concentration formula there, isn't it? Alright, so have a look at each of those. Here's the truck problem down here. Here we are. Petrol has a density of 737 kilograms per cubic metre. A tanker truck used for transporting petrol has a capacity of 30 kilolitres. Calculate the mass of petrol in a fuel tanker truck. Round your answer to the nearest tonne. Oh, there we are. So kilograms and tonnes. Do you know the conversion? 1,000 kilograms in a tonne. Okay, so you'll need to know that one. Okay, 1,000 grams makes a kilogram, and 1,000 kilograms makes a tonne. Okay, so you might have a look at that. Let's go down. Swimming pool problem. Okay, calculate the concentration of chlorine needed to actually keep that clear, that pool, keep the bacteria down. And so you need the volume and the concentration. You can work out if he adds 2.1 grams. So there's some interesting practical problems here. It's going to help you a lot in science and in just everyday living, actually, if you're going to dose your pool with antibacterial solutions and solids like chlorine. Okay, here's some more. Have a look and got some answers down here to this next one. Reasoning, getting hard, you've got to reason it out. Okay, come down, and there's number 12. Okay, have a read and have a go. And then finally, we have the open-ended questions, and here's some sample answers. A couple of different ways of approaching these problems, and there's your sample answers. Okay, well, congratulations, you made it. It's party time, so I think you deserve a party. I can't stay with you now. I've got to go on to the next presentation. But from me, it's cheers for now.